Happy learning. Welcome you all for this short video on queue data structure. I am Dr. Princess Maria John, Assistant Professor, Department of Computer Applications, Hindustan College of Engineering and Technology. To start with, in this video we are going to see about the introduction of queue, definition and properties of queue, and how queue is to be implemented and the different operations of queue. Coming to the introduction of queue. So queue is a linear data structure like a stack, and this queue follows a special principle of first in first out. They are widely used in computer science and real world applications to manage different tasks in a sequential order. A simple example for this queue can be any queue can be considered. For example, like uh, booking ticket. For booking any ticket like railway ticket or air ticket, we stand in a queue. Okay, so that is a simple example. So this queue also operates in the same fashion as a normal queue, where in normal queue the person in the front of the queue will be served first and it will be moving out of the queue. Same way here, removing from the queue is done in the front, and people entering the queue will be at the back of the queue. Here also data will be entered at the back of the queue. So from this diagram you can see where front and the back of the queue, where you have a deletion from the front and entering of queue is done from the back. Coming to the definition and properties of the queue. So this queue follows a first in first out principle, where the elements which are to be added are added in the front of the queue, and which are to be deleted or deleted from the rear of the queue. And here the element which is inserted first is the one which is deleted first or removed from the queue first. So the add operation or adding an element to the queue is known as enqueue, and removing an element from the queue is known as dequeue. Removing or deleting an element from the queue is known as dequeue. Okay, and based on the size, based on the um, size, like how whether you can add elements dynamically or it should be fixed. Based on that, it is classified as bounded and unbounded. So bounded in the sense the size of the queue cannot be increased, it is fixed. If you have allotted a queue for storing 10 elements, only 10 elements can be inserted into the queue, not more than that. So another one is the unbounded, where the size of the queue can be increased as and when there is a requirement. Element can be inserted into the node and the node can be attached to the queue. So in unbounded there is no fixed size, any number of element can be added to the queue. Implementation of this queue can be done using arrays and linked list. First one is array. So in case of array, the size of the array is fixed, it cannot be increased. So this is a bounded one. Okay, so if the array size is 10, only 10 elements can be inserted into the array. And this another, you can have a circular array or you can have circular queue. So this works in a circular fashion. Like for example, when array is used for implementing queue, the index, if your the size of the array is 10, the first element will be inserted in index 0 and the last element at index 9. So it will have a connection. So in a circular queue, once if the last element is or the rare pointer is at 9, the next element which will be inserted at index position 0 if that position is empty. If there is no data in index position 0, it will be indexed. So it is a circular fashion, it will be circulating. Okay, so if it is a linear structure, like, then the front pointer and the rear pointer will not be connected, but in this case here it can be inserted. So for array implementation of a normal queue or a circular queue, there is only two operations, like adding an element to the rear of the queue, which is enqueue, and deleting an element from the front of the queue, which is known as dequeue. So implementing queue using linked list. So it can be implemented using a single linked list, where you will have two pointers, one for the front pointer and one the rear pointer. Front pointer will be in the beginning of the queue and rear pointer will be at the end of the queue. Same way as we saw previously, here also enqueue operation and dequeue operations can be done. Enqueue adds a new node to the like at the end of the linked list or at the rear of the linked list and updates the new pointer. Where dequeue removes the node from the front of the linked list and updates the front pointer. So you will see an example here. There is a node which is having data as 25, and each node will be divided into two parts, one data part and the next part. Data part will be having the value, next part will be having the pointer to the next node. So here you will have a header, the first node will be pointing to the header node, okay, and the next part of the first node will be null if there is only one node in the queue. And the second node here inserted is having value or data 50. So this is inserted at the back of the queue. So when it is inserted at the back of the queue, the rear pointer will be moved one position. So in the second case, node front pointer will be pointing to node 1 and the rear pointer will be pointing to node 2. When you add third element, so the third element added here is 75. When 75 is added, same way the front pointer is not moved, it is pointing to node 1. The rear pointer is moved by one position and it is pointing to 75. So each time, like whenever a new node is to be or new data is to be inserted into the queue, a node will be created, data will be inserted into the queue, and this node will be linked to the last node of the queue which is existing, and the rear pointer will be incremented or moved by one position. This is for enqueue. Next one is dequeue operation. So for dequeue operation, the deletion is done from the front pointer. So here in this case, the front pointer is having node value as 25. So it is deleted and the front pointer is moved by one position. So now the front pointer is pointing to node which is having value 50. Then basically there are two operations, adding an element to the queue and deleting an element from the queue. So adding an element to the queue is termed as enqueue. Removing or deleting an element from the queue is known as dequeue. And one more operation is done, that is like peek operation. It is just for inspecting or it is for viewing the elements at the front of the queue without removing it. That's all for queue operations. Thank you for watching this video.